All right, folks, right now, what we're going to start covering is a concept that deals with patterns, okay, which is, obviously algebra in itself is recognizing, interpreting, and identifying patterns, but this is going to be a series of special patterns. They are called, we're going to basically look at sequences, yes?
Do you have a charger I can use for my laptop? I left mine in my car and I wrecked.
I do not. I'm sorry.
No, this weekend.
All right, so we're talking about two things in the next couple weeks. Now, these next 3 weeks are going to be kind of odd, all right, because we've got this week, starting Wednesday, we have 3 consecutive 2-hour delays, right? Now, we will be doing work in those 3 hours or those 2-hour delays, okay? Now, next week we have a full normal week with a 2-hour delay on Friday. The following week, we actually have 2 3-hour delays on, I think, Tuesday and Thursday, and then a 2-hour delay on Friday. Those 3-hour delays are going to be 13-minute class periods or something like that. They're ridiculously short. We will still do something on this, so when you come here those days, be prepared. I'll remind you as we get closer. We will do something those days. Say again? Wednesday, Thursday, and Friday are all 2-hour delays. No, they're 2-hour delays this week. Okay. So over the course of 3 weeks, if we sit down and think about it, we got today, we got tomorrow, those are full days. Okay. Then we get basically the end of the week with the 3-hour delays. That all accumulates to about a day and a half of class. So we got 3.5 days this week. We'll have 4.5 days next week. So that gets us up to what, 8? Okay, and then we've got like 2.5 days the following week. I guess we got like 10.5 days of class through the end of April. Okay, there's just kind of, my hope is to get through at least this chapter 9 with things called sequences and series. Okay. So we're looking at patterns, and really today, like you already know a lot of these patterns, and we've used algebraic concepts already to analyze some of these patterns. Okay. Today is going to be a learning procedure with like terms and how we write terms and how we write notation, and maybe then investigate some interesting patterns. Okay. So a sequence is an ordered list of numbers, and it's separated by commas. Okay? A sequence is an ordered list of numbers separated by commas. Eventually, we'll talk about something called a series, which is an ordered list of numbers that we add together. So they'll be separated by plus signs or minus signs. Okay? So a sequence and series, they're hard to remember which one's which. Sequence separated by commas. Okay. A term, that each one of the individual items in the sequence is called a term. Okay. So as we represent each term in a sequence with a variable, it can be any letter that we want. They usually use A. A lot of times they use T. Sometimes they'll use the letter A. A lot of times they use for a sequence that is said to be arithmetic or explicit sometimes. T is usually used in other courses or other textbooks when it's called a recursive sequence, which we'll see some of those here in a little bit. But it doesn't matter, A or T. Sometimes T for term, right? Does that make sense? Okay. But we use a variable and then a subscript number. Okay, so a subscript is a number at the bottom right-hand corner. We do nothing with it in regards to a calculation. It tells you the position something is in the list. Okay, so when I look at this, okay, so and I don't have any specific values right now, but if I had a list of values, okay, let's say that we have our first term, let's say it's 4. And then our second term is 8. And our third term is 12. And we keep going. Okay? And then we'll get to these in a little bit. And I don't know how many I've put in here, so I can't really define these directly. But if we look at this, okay, the first term is being called A sub 1. A sub 1 is how we say that. Okay? So we'd say A sub 1 is 4. The 1 tells me it's the first term in the list. Does that make sense? Okay. A sub 2 is 8. Tell me the second term in the list is 8. A sub 3 is 12. Okay. Now, A sub 4, A sub 5, A sub 6, A sub 7, A sub 8, A sub 9, all of them are in here in these ellipses, right? The ellipses say that we follow the same pattern as we've already established. So if I say, what is the pattern here? 4 to 8 to 12, what are we doing? Adding 4 each time, right? So A sub 5, you can say, is going to be 16, right? A sub 6 is going to be, A sub 4 is going to be 16. A sub 5 is going to be 20. A sub 6 is going to be 24, okay? So we can keep going through there, okay? And as we come out the other side of this, okay, this term here is going to be 1 less, and that's how we identify that this is the 1 less than the term here, or it's in the position to the left of the next term. Does that make sense? Okay, so if I had, let's just go ahead and look at this written this way real quick. So if I have A sub 1 was 4, A sub 2 is 8, A sub 3 is 12, okay, so I'm just going to go out to 10 things. If I looked at these and I said, okay, would you guys agree? Let's just say we were looking at these first 4. Okay? If that is A sub n, does it make sense that that one is A sub n minus 1? And this is A sub n plus 1, right? Okay? So each one of these terms is referred to as an A sub n. Okay? Now that n might be the third term, or it might be the 12th term, it might be the 1,000th term. But when I say A sub n minus 1, I'm talking about the term that came prior. Does that make sense? Okay? If I say A sub n plus 1, it's the term that comes next. What if I said A sub n minus 1 minus 1? If I subtracted 1 from this one, doesn't that get me in that position right there? So if I go A sub n minus 1 minus 1, okay, which is equivalent to A sub n minus what? 2. So if I started here at that being A sub n, okay, if I go 2 terms to the left, is that term? Does that make sense to everybody? So these subscripts are telling me locations of other terms based on a sub n, an initial term. Okay? And I can start anywhere and say, okay, a sub 8, let's let that be my a sub n. So if this is a sub n, then this would be a sub n plus 1. This would be a sub n minus 1. What would this one be called if I started at a sub 8? If a sub 8 was a sub n, this one would be a sub n plus 2. And what that does, it gets me to move to different positions in the list. Is that all right? Okay. We have what we call explicit formulas. Okay. An explicit formula provides the nth term of a sequence by using the number n. Okay? So when you told me, you were taking, Austin said that we're adding 4 each time, right? Okay? So if I started with a sub n, okay, and I wanted to figure out what its amount was. So if I wanted to know, let's say that my goal here is to find what a sub 5 was. Okay? But you knew the first term was 4, right? Okay? So let's just say, let's write this way. You knew a sub 1 was 4. What do I do with 4 to get a sub 2? Sub. S-U-B. So I want a rule for a sub n. Okay? You knew a sub 1 was 4. A sub 2 was 4 plus 4, right? A sub 3 was 4 plus 4 plus 4, right? Okay, so that's where we're going here. Let's do it this way first, though. Would you guys agree that a sub n, okay, so let's visualize a sub 5. It would be this one plus 1 more 4, wouldn't it? Is this one here the previous one plus 1 more 4? Is this one here the previous one plus 1 plus 4? Or plus 1 more 4? Okay, so this is going to be a sub n is going to be the previous term plus 4 more, right? Okay. When you write it this way, okay, when you're using the term before, okay, we have an issue, and the issue is, let's say I want you to tell me what a sub 30 is. What does that mean that I need to know? I'm gonna add 4 to something, right? But what am I gonna add 4 to? Okay, so ultimately, and so just because it's addition, we can see that it's a little bit easier by adding, but some of these patterns aren't going to be as easy to recognize that it's just addition. If I want to know the 30th term, don't I need to know the 29th term? And the only way I know the 29th term is if I know the 28th term. And then I got to know the 27th, right? So no matter, in writing a rule like this, a formula like this, in order to know the nth term, I need to know all the terms before it. So if I want to know the 1000th term, I need to know the first 999 terms, right? It can be a pain in the butt. It's doable, but it can be a pain in the butt. Now, you told me that you were seeing, okay, when I write this list out, a to the 5th is 4 plus 4 plus 4 plus 4 plus 4, right? How does this number here relate to the times that you see 4 being added together? It's the same, right? Okay? And adding the same thing over and over again is repetitive addition, which we say is multiplication. So if I want to find a to the nth, okay, it's 4 times what? It's 4 times n. And now, if I want the 30th term, which you guys have already said, well, I add 4 30 times, right? Is that the same thing as 4 times 30? Okay. So now if I want the 30th term, I know it's 120, and I didn't need to know the 29th term to get it, right? And I didn't need the 28th and the 27th and the 26th, right? So when we have the ability to do this, okay, when we're able to write a formula based on n, which is the location that an object or an item is in the list, we are creating what we call an explicit formula. Okay? So if I look at this one, okay, 2, 4, 6, 8, 10. Okay? Now here's the one thing to understand. When we are trying to produce a rule or a formula for a sequence that is like this, that goes, that we got these ellipses, and I don't have like I don't have like 20 here to end the list. We are making an assumption. We're making a guess that the pattern established here continues all forever. Okay? It doesn't have to, but we're making the assumption that it is. Does that make sense? Because this could go 2, 4, 6, 8, 21. Okay? Or 11. Okay? But here, what are we seeing, okay, that is happening with this sequence? If n is 1, n is 2, n is 3. How am I getting these values in the list based off those n values? I'm doing what? How do I go from 1 to 2, and then 2 to 4, and then 3 to 6, and then 4 to 8? It's multiplying by 2 each time, right? And that's something you have to realize, that it has to happen the same way every time. And you might get like 3 or 4 items in your list. Here we've got, what, 5? And we might see that, hey, doubling works the first 2 times. But then the third time, it's not doubling, okay? So, for instance, let's go with this one. Let's say I go... so let's say a sub 1, a sub 2, a sub 3. Let's say a sub 1 is 2, a sub 2 is 4. Let's say a sub 3 is 8, and a sub 4 then is 16. Okay? And you see here that, okay, well, I take 1 and I multiply by 2, I get this, right? I take 2 and multiply it by 2 and I get this. So right now I'm thinking 2 times n, right? That's what the pattern was right there. If I take n and multiply by 2, does it give me this 8? No. So what I thought was established here does not continue through the entire list, so that is not my explicit formula. Does anybody know what I can do? What's the relationship between these things? These subscripts and these powers, or these 2, 4, 8, 16? I'm doubling. Okay, so if I want to go using the previous term, I could say a sub n is equal to 2 times the previous term, right? Okay, that works. Okay, but then if I want the 15th term, I got to write this list out 14 terms, right? What if I take 2 raised to the first power? What do I get? 2. Well, if I take 2 raised to the second power, what do I get? Well, if I take 2 raised to the third power, what do I get? Well, if I take 4 or 2 raised to the fourth power, what do I get? So a to the nth is 2 raised to the nth. Okay? Our minds, and I'm the same way, our minds like to think linearly. Okay? We like to think about adding and subtracting things from one term to the next, or multiplying and dividing. Okay? But exponents exist as well. We can use exponential relations to help us realize what a sequence is. Okay. Now, and I would think that most people agree with this. It is difficult, and you're going to struggle with. I struggle with it. Okay. And I've been doing this a lot longer than you have. I struggle looking at a pattern and trying to piece together the positions, the n values, and what is being created in that position as the specific value to develop the explicit formula. Okay, it's hard. Okay, now there are some patterns, they're called arithmetic and geometric, okay, that will have a structure that allows us to always get the right explicit formula. But the ones we've done so far, it's kind of like we're just kind of guessing at what the structure is and seeing if that then is modeled. Okay, it is much easier to go the other route or the other direction. So they give you the explicit formula and ask you to come up with the first 6, 7, 8, 10 terms. Okay, so here's my formula, and they want us to come up with the first 6 terms. So the first term, a sub 1, all I have to do is I plug in n to be this subscript. So 2 times 1 plus 3 would give me what? 5. Okay. A sub 2, I put the 2 in for n now, and I get what? 7. A sub 3, a sub 4, a sub 5, and a sub 6. Okay. What do you see? Kind of, if I look at this way, should I put them in a row here or a column? I go 5, 7, 9, 11, 13, 15. What's the difference? It's 2 every single time, right? Okay. So when we see that difference is the same, what we're going to do is say that difference times n. Okay. Now, so this is kind of what I would do if I was trying to generate this rule from the list. Okay. So reversing the question. If they gave me 5, 7, 9, 11, 13, 15, and asked me to come up with the rule, I would first find that difference and say 2 times n. Okay? But now, what do I need to do with that? So if that n is going to be 1 right there, what would I need to do to 2 times 1 so that I generate the 5? So right now I've got a rule that is starting my formula. I got 2n. But if I put n to be 1 in here, I only get 2, right? So how do I make 2 turn into 5? Plus 3. Okay? And now I know that I've got, okay, if n is 1, plug that in, I get 5. Now try, does that work with 2? If I plug 2 in, do I get 7? See if it works with 3. If I plug 3 in, do I get 9? Does that kind of make sense? So one way of deciding what the explicit formula is, and it's not always going to work this way, but one way of finding an explicit formula is to look at the difference between consecutive terms. Okay? If we go back to this one that went 2, 4, 8, 2, 4, 8, 16. The next one would be 32. Okay? If I look at the difference here, there we see that there is not a common difference, right? Okay? Maybe I go down, look at this and go 2, 4, and then 8. and it goes down to 2 and 4 and then to 2. Okay, so looking at the common differences between the differences, we don't see any maybe structured pattern. What that tells me there is that this is going to be some type of exponential relationship. Does that kind of make sense? Okay. But at least looking at that, it would tell me that I'm not going to have, 2 times n plus 3, or 2 times n plus 4, or 2 times n minus 2, or something like that. I'm not going to have a linear relationship to explain that list. Okay. So sometimes you can determine a pattern in a sequence by comparing each term after the first term to the ones that came before it. Okay. So an example. Okay. What is happening in this list here? Going down by 5. Okay. So I'm taking the previous term, which would be a minus 1, or a sub n minus 1. That's how I say the previous term, right? Okay. So if I'm right here, even though my list started there, what would be the previous term? 115, right? Okay. If I go to 105, that's the previous term, right? If I go to 100, that's the previous term. So I go a sub n is going to be the previous term minus 5. Okay? So if a sub 1 was 110, then a sub 2 is the previous term, which is a sub 1, right? So a sub 1 is the previous term, so I go 110 minus 5. Does that give me the 105 that is in the second spot? If I go a sub 3, a sub 3 is the third term in the list, okay, which is going to be a sub n minus 1, so that's the second term in the list, minus 5. And the second term in the list is 105. It's right here. We already found it. So I go 105 minus 5 gives me 100, correct? And if I want a sub 4, it's going to be the previous term, which was a sub 3, minus 5. If I want a sub 5, it's the previous term, which was 95, and subtract 5. Now you keep doing that, right? But if I want the 100th term, we need to know the 99th term, right? We've already kind of talked about this. Okay? These types of formulas where you're using the previous term or previous terms, okay, is called a recursive formula. Okay? And these, I think you're going to appreciate explicit formulas after we deal with recursive formulas. Recursive formulas are very hard to realize what is happening. Okay, in all of these, it's hard to take the list and create the formula. If they give me formulas and tell me to generate the list, that is much easier. Okay, so that's kind of what we'll start off with initially. But so the recursive sequence needs an initial term, and it needs a relationships that create the next term in the sequence. Okay, those are the two things you always need to make a recursive sequence. So here, they're saying a sub 1 is 3. Okay, and they're saying a sub n then is the previous term plus 5. Okay, so a sub 2 would be, what this formula is saying is you would take the previous term, which would be a sub 1, right? And add 5 to it. So what do I get if I add 5 to this? Take the previous term, add 5, you get 8. Okay? A sub 3. Take the previous term, add 5 to it. Okay, so that's going to be 13. A sub 4, previous term, add 5 to it. Okay, so now here's my question. That's recursive. And if I want to find the 80th term, I would have to go out to 79 terms here, right? some recursive formulas can be rewritten. If that difference between all of them is 5, can I do something like that? Take that difference and multiply by n. Now, if I take 5 times n, that does not give me this, and n being 1. So I go 5 times 1. Does that give me 3? No. What would I need to do to get that to be 3? 5 times 1. How do I make 5 times 1 turn into 3? Subtract 2, right? Now here's my question. So if I plug 1 in, does that give me 3? Yes, it does. If I plug 2 in, does that give me 8? Yes, it does. If I plug 3 in, does it give me 13? Plug 4 in, does it give me 18? Okay. So that is the explicit formula, and this here is the recursive. And they are 2 different rules that give me the same exact list. The recursive one, if I want the 1,000th term, I got to write 999 of them out, right? Using the explicit, if I want the 1,000th term, I take 5 times 1,000 minus 2. It's 4,998. Okay. You guys ever watch the Da Vinci Code? The movie, the Da Vinci Code? You ever watch it? It's a Tom Hanks movie. Oh man. No, but one of the so they talk about the Fibonacci sequence. Okay. And the Fibonacci sequence starts like this. Okay. And what we're going to do is we'll take these 2 numbers, add those 2 numbers together. What do you get? You get 1, right? Now, you're going to take this, and you're going to slide it and compare those 2. Add those 2 together. What do you get? 2. Okay? Now, add those 2 together. Okay? So now I'm going to add these 2. What do I get? And now these 2. And now these 2. And then this is going to give me 34, 55, 89. Okay? That's called the Fibonacci sequence. Okay? Fibonacci is the guy that recognized it. Okay? Or realized it. Okay? The way the Fibonacci sequence is defined, okay? So let's say this is the nth term, and we use a capital F here because of Fibonacci. Okay, so let's say I want to find the nth term of the Fibonacci sequence. Didn't I take the previous 2 and add them together? Okay, so the previous term, so if 89 is the term I'm interested in, then the previous one would have been f of n minus 1, right? And then I add to that the term previous to that, which would be f sub n minus 1, which is minus 2. So that says add the previous 2 terms together. Okay? What happens, and there's a lot of different places in the real world that uses the Fibonacci sequence. So the Fibonacci sequence is realized the way a lot of trees that branch off from the trunk at different levels. The first level is a lot of times there's 1 branch. At the second level, there's 2 branches. At the third level, there's 3 branches. Okay, in situations that an organism tries to reproduce or maximize itself, the Fibonacci sequence is realized. Okay, think about a tree. What's a tree trying? Why is a tree branching off like it does? What's it trying to do? What do the leaves do? They consume oxygen. They consume CO2, don't they? Okay. And they need light. Do they not need light to do that? So they need to space themselves out, right? Okay. And a way to do it to maximize their potential consumption of space is to organize themselves in the Fibonacci sequence, okay? Think about sunflowers. You guys ever looked at the inside of a sunflower? Like the... Pine cones are the same way. All right, do you see? So there's a pattern to this, right? Okay, and I'll find. I think I got better pictures somewhere else. But the way that the sunflower has a need to try to fit as many seeds inside this circle as possible, right? Okay, that's an organism's purpose, or their main purpose is to reproduce as much as they can. Does that make sense? Okay, so if it's got a the size of, I don't even know what you call this on the sunflower, but that part where the seeds are, they're trying to maximize the amount of seeds that can go in that predefined area. Okay, in order to do that, they need to align themselves in the Fibonacci sequence. So if I were to look at the rows there, or the cycle, it has to go with it's the spirals here that we would count out. Okay, they end up, as I move outward in the sequence, or outward in the spiral, that Fibonacci sequence, and I count them, is matched. Okay, I think I've got, and I'll go through my video. I was looking for it earlier, but I'll go through my videos and see if I can find. I got a good one explaining the Fibonacci sequence, something that we're working on right now, and how it is utilized or realized in the real world. Yeah. There's an assignment in Math Excel 9.1. Shouldn't be too difficult. Okay. Give that a shot, and we'll talk about it tomorrow and go on from there.